This video will cover section 1.6 on other types of equations. Specifically, this video will cover rational equations. A rational equation is one in which one or more of the terms is fractional. That means there is a fraction within this equation. What's different about these equations from the ones that we did in chapter 1.1 where we did linear equations is that now there is a variable in the denominator. Since the denominator of a fraction cannot be 0, then we have to verify that our solutions do not make the denominator equal 0. So once you get your solution, you're going to fill it back in and verify that when you do fill it in, that it doesn't make a 0 in the denominator. So to solve rational equations, you first want to remove the fractions by multiplying by the least common denominator, or also called the least common multiple. Before you decide what your multiple is going to be, you want to make sure you factor anything that can be factored in the denominator. Alright, so you may have to look through, it may be a GCF, it may be a difference of squares. If there's a trinomial there, you may have to factor it, or you slide and divide to factor. So first you want to check through the denominator, all of the denominators. Alright, so anything that can be factored in the denominator, go ahead and factor it out. Alright, this will help to make sure that you get the least common or the smallest multiple that all of these denominators have in common. Alright, you're going to, once you remove the fractions and get rid of the parentheses, you're going to determine what type of equation you have. So once you remove the fractions and it's no longer rational, it's either going to become linear or it's going to become quadratic. If it's linear, you follow the 5 steps to solving it, and you should have already taken care of step 1, alright, in linear, which is remove fractions. If it's quadratic, you can do the zero factor property. Depending upon what it looks like, it may be the square root property. If you learned complete the square, you can use that. If not, then you would use the quadratic formula. Remember, this property only works if it will factor, and this one always works factoring or not. Once you get it solved, verify that your solution does not make the denominator 0. Alright, so if I look at the examples below, alright, looking at example 1, if it has a fraction, remember we want to get rid of it. So if I want to get rid of this number 2 down here in the bottom, alright, remember this line right here means to divide. So I'm going to take this number 2 and divide it into something, and I want it to go away, to cancel out, really to give me 1 is what I'm wanting. And so the only thing that 2 will divide into and get 1 is a 2. So what I'm going to do is I'm going to multiply this fraction by 2. So I'm going to come up here and say 2 times 2x minus 3. Alright, so I've now taken this fraction, multiplied it by 2. Now this 2 and this 2 will divide each other out and leave me just the 2x minus 3. And we're going to take care of that shortly. Alright, because I have multiplied this fraction right here by 2, I have to multiply everything else by 2 so that my equation stays in balance. So I'm going to come through and everything is going to get multiplied by 2. Alright, so everything's been multiplied by 2. I've taken care of this denominator. It should no longer be there once I actually go through and do the multiplication. For the next fraction, I have x plus 1, which I also need to go away. I don't need any fractions in my equation, so I need to divide x plus 1 into something that it will cancel with, or otherwise known as giving me 1. And the only thing that this will divide into and give me 1 is x plus 1. So I'm going to multiply this equation by x plus 1. I'm sorry, this fraction by x plus 1. Because I've multiplied this fraction by x plus 1, I have to multiply everything by x plus 1. Alright, so now that I've multiplied everything by each of the denominators, so everything was multiplied by a 2, everything was multiplied by an x plus 1, I'm going to go through and actually do the multiplication and cancel out where I can. So looking at the first fraction here, alright, this 2 and this 2 will divide out. And then what I'm left with is x plus 1 and 2x minus 3. Then I'm going to add to that. This x plus 1 and this x plus 1 will cancel each other out. And I'm left with 2 times 5x. Then here there's nothing to cancel out. So I'm just going to distribute that 2x in there to get 2x squared plus 2x. Alright, now that I've gotten rid of the fractions, I'm going to go through, get rid of the parentheses. So x times 2x is 2x squared. X times negative 3, 1 times 2x, and 1 times negative 3. Then 2 times 5x. Alright. Now I'm going to simplify this side, so I have 2x squared. I have a negative 3, a positive 2, and a 10. That would give me 9 x's. And then I'm just going to bring down this right side. Alright, when I look at this equation, it appears that it is quadratic because of the x squared. So if that's the case, I want to set it equal to 0. So I'm going to take everything on the right side and move it over. So I'm going to subtract 2x squared. I'm going to move it over here with this 2x squared. But notice when I move this one over here with this one, they end up canceling each other out. And so now I actually don't have a quadratic equation, I have a linear equation. So I'm going to solve for x by moving the 9x over. Alright, so I subtracted 9x where I moved the 9x over with the 2x, leaving me negative 7x. I'm going to divide that into 3. Alright, and that tells me that x equals positive 3/7. Negative divided by negative makes positive. 3/7 is as simple as it will get. Alright, I can then use my calculator to verify that my answer is correct. Alright, also what you need to do now is verify that this number right here will not make the denominator be a 0. So I'm going to come back up here to my original problem, looking at the denominators that have a variable, because that's where I'm going to be substituting my solution. Alright, this denominator does not have a variable, so you won't be filling anything in. It's not going to be anything other than a 2 ever. Alright, here I have a variable, and so when I take my solution 3/7 and I plug it in for x, 3/7 plus 1 definitely does not equal 0. Alright, so I know that my solution is good in terms of it not making the denominator equal 0. Alright, let's look at number 2 here. Alright, for number 2, I need to find a common multiple between 2x and x. Alright, so I'm looking for something that both of these will divide into, that 2x will divide into, and also I can divide x into. So if you think about what can I multiply this fraction by so that the 2x will divide out, and that would be 2x. So I'm going to multiply this fraction by 2x. Alright, and because I multiplied this first fraction by 2x, I have to multiply everything by 2x. Even if it's not a fraction, it still has to be multiplied. This keeps my equation in balance. Alright, so I've got something here that the 2x on the bottom will cancel with on top. Alright, and then I have this other denominator x, so I need something that x will cancel out with. Alright, now it cannot cancel out with this x, alright, because this x and this 1 are being added together. You cannot split them apart by division. Alright, so you can't just cancel that out. That can't happen. Alright. Alright, so I need to multiply by an x so that I have an x to cancel with the one in bottom. Alright, fortunately, when I multiplied by 2x, it gave me an x that I could cancel with. So there's no need to multiply by an additional x. You already have one here in the 2x that you multiplied by. So let's go through and cancel out and see what we have left. This 2x and this 2x are going to cancel out and leave me x minus 2. 2x times 1 is 2x. Here, this x and this x will cancel out and leave me 2 times x plus 1. Alright, then if I simplify, I'll have 3x minus 2 equals 2x plus 2. So when I look at these this one equation, I can see that it is linear. Alright, so I'm going to get my variable terms on one side. Alright, that leaves me x minus 2 equals 2. I'm going to get my constants on a side. That leaves me x equals 4. Alright, so I subtracted the 2x, I added the 2, or you can think of you move the 2x over with the 3x, and you move the negative 2 over with the 2, whichever way you like to think about it. Alright, now that I have my solution, I want to verify that it does not make my denominator 0. So if I come up here and I fill in my 4 in place of x, 2 times 4 is 8. That is not 0, so it works good there. And if I put a 4 here, that would just make it be a 4, which is not a 0. So that tells me that my solution of 4 is good.